Tornadoes are a force of nature that inspires both awe and fear. They are a spectacle of raw power, a swirling vortex of wind capable of unimaginable destruction. These violent storms, born from the clash of atmospheric forces, leave a trail of devastation in their wake. The sheer unpredictability of tornadoes, their sudden appearance and capricious path, adds to their mystique and danger. Then, out of the swirling mass, a funnel descends, a column of dust and debris reaching towards the ground. The roar of the wind is deafening, a primal scream that chills the very soul. This is the raw power of a tornado, a force that can obliterate buildings, uproot trees and toss cars like toys. Tornadoes remain a force of nature that we can only marvel at and fear. Tornadoes are born from a unique set of atmospheric conditions, a delicate balance of factors that combine to create these whirling vortices of destruction. The process begins with warm, moist air rising from the ground, creating an unstable atmosphere. As the warm air rises, it cools and condenses, forming thunderclouds. Within the storm clouds, strong updrafts and downdrafts create a swirling motion, a vortex of air that begins to spin faster and faster. When the funnel cloud touches the ground, it becomes a tornado, a destructive force unleashed upon the landscape. The formation of a tornado is a complex process, a delicate dance of atmospheric variables. Atmospheric instability is the driving force behind tornado formation, the fuel that powers these destructive storms. It is a condition where the atmosphere is primed for a rapid vertical movement of air, creating the updrafts and downdrafts essential for tornadogenesis. Imagine a pot of water on a stove. As the water heats up, the hotter, less dense water rises to the surface while the cooler water sinks. This continuous cycle creates convection currents similar to an unstable atmosphere. Warm, moist air near the ground is less dense than the cooler air above. This difference in density creates an unstable equilibrium where the warm air rises. Wind shear enhances this instability, creating horizontal rotation that can form a tornado. The formation of a tornado is a delicate dance of air masses, a complex interplay of updrafts, downdrafts, and wind shear. It is a process that transforms the chaotic energy of a thunderstorm into a focused vortex of destructive power. Understanding this dance is key to unraveling the mysteries of tornado formation. Imagine a spinning top, its rotation fueled by the flick of a finger. In a similar way, the spinning vortex of a tornado is initiated by the interaction of different air masses within a thunderstorm. Warm, moist air rising from the ground creates updrafts, while cooler, drier air descends in downdrafts. Wind shear, a change in wind speed and direction with height, plays a crucial role in this dance. It creates horizontal rotation in the atmosphere, which is then tilted vertically by the updrafts. This tilting motion transforms the horizontal spin into a vertical vortex, the defining feature of a tornado. As the vortex strengthens, it draws in more air from the surroundings, intensifying its rotation and power. The funnel cloud, a visible manifestation of the spinning vortex, descends from the thunderstorm cloud base, reaching towards the ground. When the funnel cloud touches the ground, a tornado is born. Predicting tornadoes is a challenging task, a constant battle against the unpredictable nature of these destructive storms. Advancements in technology and atmospheric science have significantly improved our ability to forecast these events. Doppler radar detects rotation within thunderstorms, identifying areas of strong rotation. This allows meteorologists to issue tornado warnings, alerting the public to the imminent threat. Numerical weather prediction models simulate atmospheric conditions, forecasting severe weather events. Ongoing research and technological advancements continue to improve our forecasting capabilities. Tracking tornadoes is crucial for mitigating their impact. Timely warnings allow people to seek shelter and minimize casualties. Radar technology and storm spotters provide real-time information about these dangerous storms. Doppler radar detects storm movement and rotation, indicating tornado presence. Storm spotters report funnel clouds and severe weather, supplementing radar data. Together, they provide a comprehensive system for tracking tornadoes and issuing warnings. Tornadoes are a force of nature capable of unimaginable destruction. Their powerful winds, reaching speeds of over 300 miles per hour, can obliterate buildings, uproot trees, and toss vehicles like toys. The destructive impact of tornadoes extends beyond immediate damage, disrupting communities, economies, and lives. The most devastating tornadoes can level entire towns, leaving behind a trail of debris and despair. The human cost of these storms can be immense, with injuries, fatalities, and long-lasting psychological trauma. It underscores the importance of preparedness, early warning systems, and resilient infrastructure to mitigate the impact of these devastating storms. The Joplin tornado of 2011 stands as a chilling testament to nature's destructive power. This catastrophic EF5 tornado ripped through Joplin, Missouri, leaving a path of devastation over 6 miles long. The tornado claimed 158 lives, making it the deadliest single tornado in the US since 1947. Thousands of homes and businesses were destroyed, leaving a significant portion of the city in ruins. The recovery process was long and arduous, requiring immense effort and resources to rebuild the city. The lessons learned continue to inform disaster preparedness strategies to protect communities from future tornadoes. The aftermath of a tornado is a time of immense challenge and resilience. Communities grapple with the devastation, rebuilding homes, businesses, and lives shattered by the storm's fury. The recovery process is long and arduous, requiring a collective effort to heal and emerge stronger. The immediate aftermath is marked by chaos and urgency. Rescue workers search for survivors, medical personnel tend to the injured, and emergency shelters provide refuge. As the initial shock subsides, the focus shifts to rebuilding. Homes and businesses need to be reconstructed and essential services restored. The aftermath is also a time for reflection and learning. These lessons inform future efforts to mitigate the impact of tornadoes and enhance community resilience. Tornadoes are a powerful force of nature, but we can take steps to protect ourselves. Preparedness and timely response are crucial for surviving these storms. By understanding the risks and heeding warnings, we can stay safe. Having a safe room or shelter is essential. This area, typically a basement or interior room, protects from debris and winds. Stock it with water, food, flashlights, and a first aid kit. Pay attention to weather conditions and warnings. When a warning is issued, seek shelter immediately. Stay away from windows and doors. If outdoors, seek a low-lying area and cover your head. Tornadoes are a testament to the raw power of nature, a force that commands our respect and demands our preparedness. Despite our technological advancements, we are still vulnerable to the unpredictable forces of the Earth's atmosphere. The study of tornadoes is a journey into the heart of nature's fury, exploring the complex interactions that give rise to these storms. As we research and understand tornadoes, we must prioritize preparedness and mitigation strategies. By investing in early warning systems and educating communities, we can minimize the impact of these devastating events.